Hi students, now in this video lecture we will discuss factors that favor corrosion, prevention of corrosion and advantages of corrosion. Now, factors that favor corrosion. Since we know that corrosion is a reaction of metal with its environment, that is reaction of metals with atmospheric oxygen, water vapor and carbon dioxide. So this corrosion process in which metal is reacting, right? So it depends directly on the reactivity of metals. More the reactivity of the metal, more the corrosion. So more reactive metals will favor corrosion, right? If we look into the electrochemical series, the metals at the top are more reactive, so they get corrode easily as compared to metals which are below in the series, right? Like gold. We know that gold, even if it is placed or exposed to air for 100 years, it won't get corrode. Why? Because gold is least reactive in the activity series, right? So metals that are below in the activity series don't get corrode easily, whereas the metals which are above in the activity series will get corrode easily, right? Because of their reactive nature, highly reactive nature. And the second is dissolved salts in metals. We know that iron gets more easily rusted in seawater, right, as compared to distilled water or if it's placed in air. Why? Because seawater contains salts, right, and salts act like electrolytes. So this presence of electrolyte favors the corrosion, right? So dissolved salts in water or in seawater, right, will act as electrolytes and will favor the process of corrosion. Presence of less reactive metal. Suppose we are trying to prevent the corrosion of iron, right? And if we coat iron with a less reactive metal, that is the metal which is less reactive than iron, right, then in that case corrosion of iron won't get stopped, right? If there is a little scratch, suppose we have coated iron with tin. Let's take an example. If we have coated iron with tin and tin is less reactive than iron, right, and if there is a scratch, right, on this plating of tin, right, then iron will again start reacting because the iron will get exposed, right, to atmosphere, right? Then instead of tin, right, which is less reactive, it's iron that will again start reacting and will start the process of rusting and will start getting rust again. Whereas if we talk about metals that are more reactive, if we coat more reactive metal on iron, for example zinc, right, if you coat zinc on iron, even if there is a scratch on this coating, then since we have zinc on iron and zinc is more reactive than iron, so zinc will react preferentially compared to iron, right? And this coating of zinc on iron is known as galvanization, and coating of tin on iron is known as tinning, right? And we say that galvanization is always preferred over tinning. Why? Because galvanization will prevent rusting, whereas tinning may not prevent rusting, right? So we say in presence of less reactive metal, for example we have tin which is less reactive than iron, right, and we have zinc which is more reactive than iron, right? So this is known as galvanization, right? This is not known as galvanization, but if we coat zinc over iron to prevent the rusting of iron, right, then rusting would be stopped. Whereas if you want to promote or if you want to favor rusting, then you need to coat metal which is less reactive compared to iron. Since we are doing favorable factors for rusting, then if suppose this is an iron rod and you have coated tin over it, right, and suppose there is a scratch somewhere on this coating, right, then instead of tin, since we know that tin is less reactive than iron, right, so tin will not react, and instead if some part of iron on this rod is exposed to air, this iron will start reacting with oxygen and water vapor, right, and will start the process of rusting, right. And preference would not be given to tin, because we know that tin is less reactive than iron. So more reactive metal will start reacting. So if we have less reactive metal, then the other metal which we are trying to prevent rusting for will start corroding, getting corroded, right. Then presence of pollutants, like if we have carbon dioxide, nitrogen dioxide in air, this will also favor rusting. Why? Because favor rusting or corrosion. Why? Because these pollutants will start attacking the metal surface, forming different chemical compounds, right, which will again give a dull appearance to the metal, right, because we know that it is due to the formation of chemical compounds that rust or different compounds get formed, right. Due to the formation of those compounds, right, a metal will acquire a dull look, because the metal surface gets covered with those chemical compounds, right. And metallic impurities like carbon and sulfur. If a metal has carbon or sulfur as an impurity, then carbon will also react and sulfur will also start reacting with oxygen that is present in air, and it will form, and with water vapor, along with water vapor, it will form carbonates and sulfates, right, which will again add to the process of corrosion, or which will again promote corrosion, right. So impurities like sulfur and carbon will promote corrosion by reacting with the atmospheric oxygen and water vapor, forming carbonates and sulfates. Now let's see how can we prevent rusting, right. Since suppose this is an iron rod, right, and this is placed in air, this rod is placed in open air, right, and in air we have water vapor, we have oxygen, we have carbon dioxide, all these gases, right, will attack the surface of iron, right. And when it will attack the surface of iron, what it will form is, we know that if we have gone through this in previous lecture, it will form ferric oxide, which is nothing but rust, brown colored rust, right. So since these gases are reacting with metal surface, right, so what can we do to prevent this reaction? Because prevention of corrosion prevention of corrosion is preventing this reaction that is taking place at the surface of metals, right. So if we can somehow stop these gases and water vapor attacking the surface of metal, we can go ahead and prevent rusting, right. So to prevent rusting, stop reaction of gases with metal surface, right. So how can we prevent these gases attacking metal surface? If we somehow cover this metal surface, right, with anything, so once you cover this metal surface, these gases won't come in direct contact with the metal surface, right. So what you can do is, to stop reaction of gases with metal surface, cover metal surface, cover metal surface. So how can we cover metal surface? We know that rusting of iron takes place, right, and in order to prevent the rusting of iron is painted regularly. The reason for painting iron material is to prevent rusting, right. So when iron materials are painted, when oiled or greased, you apply grease on it, you apply oil on it, right, or you paint it, what you are basically doing is you are trying to prevent this metal surface, right, from coming in direct contact with air, right, because if it will not come into direct contact with air, it will not react with these air components to form this hydrated ferric oxide, which is rust, right. So cover metal surface. How can we cover metal surface? By painting, by oiling, by greasing, these are the ways, because with using these ways we can prevent contact between metal surface and air. So once you can, if by any method you can stop this metal surface from coming in contact with air, you can prevent rusting. And there are ways. I told you first, oiling, painting, greasing, right? Then there is something known as barrier protection. If you put a barrier between metal surface and air, right, that is known as barrier protection. And by barrier protection you can do using painting, oiling, greasing. This is nothing but barrier protection, because you are putting a barrier of oil or a barrier of paint on the metal surface, so that metal surface does not get in contact with air directly, right? Then there is something known as sacrificial protection. Now what is this? What is getting sacrificed? Sacrificial protection is the thing that we have discussed here, right? Whether we plate zinc on iron or whether we plate tin on iron, this, when we plate, here we have studied factor that can favor corrosion, right? So when we are trying to favor corrosion, we are plating less reactive metal, right, on the metal surface, so that the metal underneath it will start getting reacting in preference to the metal which is plated. But we have seen in case of zinc, which is more reactive, right? So what zinc will do, if you plate zinc on iron, zinc will always react in preference to iron. Why? Because zinc is more reactive than iron, right? So sacrificial protection is when a metal is coated with another metal, right, that can react preferentially, right, and undergo reaction with air, right, in preference to the metal which you are trying to save, right? So if you have, say, iron rod, this is iron rod, right, and suppose you have plated this with zinc, right, and we know that zinc is more reactive than iron. So zinc will react preferentially, right, with air in comparison to iron. Why? Because zinc is more reactive and can easily get oxidized. So sacrificial protection is clear. It's just a coating of a more reactive metal, right, to save the baser metal, right, so that baser metal won't get the baser metal that you are trying to save won't get react with air. Instead, since we have a coating of more reactive metal on it, that more reactive metal will always react and prevent baser metal from coming in contact or from reacting with air, right? So it's a coating of more reactive metal like zinc on iron, right? And this is known as, we have studied, this is known as galvanization, right? This is known as galvanization. Galvanization can prevent rusting or corrosion of iron. Galvanization can prevent rusting or corrosion of iron because it is more reactive than iron and will always preferentially react or oxidize in preference to iron. Now, cathode protection. Cathode protection is, we have already discussed and gone through in detail the chapter electrolysis before this, right? So cathode protection is when, if suppose this is the case, we are trying to save metal iron from rusting, right? So what we do is, the metal that we are trying to save, right, suppose this is the case, right, this is cathode and this is anode, right? And if we are trying to save iron, right, so what we will do is, we will connect iron with zinc with a wire. We will connect this using a wire. We will connect to both these are metals. Cathode is always made metal to be saved, iron, and anode is always made with which the other metal which you are trying to save with. We are trying to save iron with zinc, right? So zinc here is made anode, and anodes will always be more reactive. In this case also, anode will always be more reactive than iron, so that anode will preferentially lose electrons, right, and it will prevent the consumption of this iron. It won't let iron react because anode is more reactive, so it will lose electrons and enter as ions in the electrolyte, right? So cathode protection is clear. Just remember that metal to be saved is placed at cathode, and the other electrode, which is anode, is made of more reactive metal, which is zinc, right? And the other is advantages of corrosion. What could be advantages of corrosion? We have studied in the previous lecture that aluminium, when corrosion of aluminium, if you remember the corrosion of aluminium, aluminium will react with oxygen. Aluminium, when placed in air, right, it will get corrode, right? That is, it will react with atmospheric oxygen, right, forming Al2O3. This is oxide of aluminium. This is sticky, right? It will stick to the metal surface. It will stick to aluminium, right? Since it sticks to the surface of aluminium, it won't let aluminium come in direct contact with air due to the formation of this oxide, right? Due to the formation of this oxide on aluminium, the aluminium would not get in direct contact with air. Hence, further corrosion of iron is saved. Further corrosion of iron is prevented due to this protective layer of oxide, which is aluminium oxide, right? So aluminium oxide, so this is advantageous. This corrosion, this, what is this? This is nothing but corrosion, and due to this corrosion, further corrosion of aluminium, right, is prevented, right? Because aluminium, this was the metal, right? On this metal surface, this reaction occurred, and on this metal, this layer of zinc aluminium oxide gets formed, right? And this layer of aluminium oxide is sticky, right? It will stick to the surface of aluminium, and further the aluminium is now due to the formation of this oxide, aluminium is no more in contact with air, right? So this oxide will stop further reaction of aluminium with air, and hence it acts as a protective layer. Due to this protective layer, further corrosion of aluminium is prevented, and this is known as advantageous corrosion, right? So this is one of the advantages of corrosion. Advantages of corrosion: formation of oxide in case of aluminium, which acts as a protective layer, right, to prevent further corrosion. Protective layer is of aluminium oxide, which is sticky, it sticks to the surface, right? And it's not like iron, because oxide also gets formed when iron reacts with air. But in case of iron, what happens is iron forms an oxide, but that oxide is not sticky like aluminium, right? That oxide is a powdery oxide, powdery oxide or amorphous oxide, kind of porous. It's generally, we call it as porous. That is, it's a porous material that will fall off from the surface of iron, right? And hence further